Hello, guys. So, so we are talking about Hadoop 2 at eBay. We recently deployed Hadoop 2 after 6 months of testing, hardening, fixes into our production cluster, into our biggest production cluster, which is Al. So here's the agenda of the talk. We'll talk about who we are, what is our then we'll talk about background of Hadoop and specifically what is the background of Hadoop at eBay. What are the challenges which we face, how we fix those, what are the still problems we have, some of the solutions I've tried to put together, and then what are the good things which we learned and what are the benefits we are getting out of the Hadoop 2. Who I am. I'm Mayank Bansal. I'm principal engineer at eBay, Apache Hadoop committer, Apache Uzi PMC and committer. Currently, I'm leading Hadoop core development for MapReduce and Yarn at eBay. In the past, I was working on scheduler, resource managers, working on distributed system, data pipelines, all kind of things. So this is about me, but so who we are. In eBay, we are around 40 people who is working on developing and supporting Hadoop, specifically for internal Hadoop users. We have thousands of Hadoop users at eBay, which, I think they are the most creative Hadoop user community I've seen. Anything new comes up, they just started using it, and they ask us to support them. Anything new, they just wanted to use it. They are pretty much creative and pretty supportive. If you ask them, 6 months before we asked them, we wanted to do Hadoop 2, they were so much supportive. They tested their jobs, all the jobs, and again and again and again. So I really love our Hadoop users. So let's talk about background of Hadoop and Hadoop at eBay. So Hadoop evolution at eBay is like any other company, but it grew a little faster. In 2007, we started with a 10-node cluster. 2009, we have 50 plus nodes. 2010, we have 100 plus nodes, thousands of cores, 1 petabyte of data. 11, 1,000 plus nodes, 10,000 cores, 10 petabyte of data. 12, 3,000 plus nodes, 30,000 cores, 50 plus petabyte of data. Right now we are this, 10,000 nodes, 150,000 plus cores, and 150 petabytes of data. So this is how we rapidly growing our Hadoop clusters. As we speak, we are growing right now. Somebody is increasing more nodes in our clusters. So this is the evolution. And we've looked at Hadoop 1. We used Hadoop 1, and then we started. So this is Hadoop 1 architecture, right? We have clients, we have job tracker. Job tracker is talking to task trackers, assigning tasks. It works well. It works pretty well. But the way we are growing, we started hitting limits. And 6 to 7 months back, we thought it's not going to work out more because the way we are growing. So these are the limitations of Hadoop 1, right? We can maximize our cluster to 4 to 5K nodes. Concurrent tasks are around 40K. Job tracker is not going to scale because there are memory limits, and it has the locks. The job tracker has locks, which, if you do any task tracker give a heartbeat, it has to lock and update the status. So that's not going to scale. Any failures kills all the jobs. So in Hadoop 1, we have a hard partition of map and reduce tasks, which is boils down to actually a less cluster of utilizations. And there's no alternate paradigm other than MapReduce. We wanted to use streaming. We wanted to use interactive queries. We wanted to use so many things, right? And Hadoop 1 was not able to, because it's a batch processing. It's inherently is not supporting all these functionalities. So because of this, then we looked at Hadoop 2, which is actually multi-purpose systems. It does very well for batch processing. It does very well for interactive. So MapReduce, Thais, all these new functionalities, Storm, streaming functionalities. I mean, you can do actually in terms of anything in Yarn, right? So we wanted to do Hadoop 2. This is when we started testing Hadoop 2, using Hadoop 2. We deployed 400 node cluster just for testing, just for hardening, just to start using it. So this is Yarn. We have clients, we have resource manager. So actually, in Yarn, we broke down job tracker into two things, which is resource manager and application master. So the resource manager just manages the resources of all the nodes, and the application master actually manages the application. Any application-specific data managed by the application master, and all the cluster-specific resource management is done by the resource manager. So the application master, so once client submits a job to the resource manager, what happens is resource manager talks to any of the node manager and tries to find a slot for the application master to run. Once the application master launches on the node manager, then resource manager gives all the delegation to the application master to manage the application. And it directly talks to the node manager and launches containers. And then it tells resource manager that these many containers I need. Resource manager and then application master do a negotiation on the resources through the RMAM protocol, and then they launches containers, application finishes. So this is how it's going to scale now, right? So we have application, so you can run multiples of application master. There is no load on the resource manager. To be very frank, I can run resource manager for a 2,000 or 3,000 node cluster on a 10 GB RAM. I mean, that's what resource manager I can run right now. This is how resource manager now gonna scale. Because all the heavy lifting has been divided between the application master and the resource manager. So this is pretty much a scalable architecture which Yarn provides right now. So we deployed one of the biggest Hadoop cluster with Hadoop 2. So definitely it's not going to be easy, right? So we found some challenges. I'm going to share with those with you guys. Application master is just explained. It's the because of application master we could scale, but it comes with some of the problems as well. The first problem is it runs on the normal node manager machine. So right now, before in Hadoop 1, job tracker runs on an enterprise machine, right? You don't have a flaky machine which can go down. However, in Hadoop 2, application master runs on a machine which can go down. If you have a 2,000, 3,000 node cluster, it will go down. I mean, the machine goes down every, day. And so this runs on a commodity hardware, and that's when the problem comes in, right? Because now you have to deal with, because application master manages the whole application, and if the machine goes down, your application will go down. Your job will fail. We found so many out of the memory errors from the application master because we run jobs like 200K tasks each job, and application master has to scale. We have slow machines because some problem will come. NIC goes down, or it's very slow, or so many problems with the slow machines, right? So your machines go slow, and then you have to, and if the application master is running on those machines, that's a big problem for that particular application or whatever the application master is running on that machines. Flaky network. The network can be bad between the data nodes. And in that scenarios, we found some of the issues with the application master. Nodes goes down. In MapReduce, we solved this problem through job history files. So whenever the MapReduce job runs, it creates the job history files. And the application master, when it fails, it can rebuild its state from the job history files. So the application doesn't fail. Only the application master will be shifted from one machine to another machine, and it rebuilds its states, and it continues. So that's how we solve this problem into the MapReduce. But it's still problem in the generic applications, because the basic advantage of Yarn is we can run any kind of application, right? We solved this problem in MapReduce, but we didn't have solutions for a generic application. Suppose if I wanted to run any, let's say, distributed shell, right? It's not a MapReduce application, and then I don't have any solution for if the application master goes into the machine which goes down. We solved this problem through application timeline history server. This is going to be released in 2.4 release of Hadoop, which the vote is going on. Still, it's not, I will say, production quality. These are the two Jiras, 321 and 1530, where we are working on it. We don't have the security on this right now. We will be doing it into the next release, the security, as well as there is some issues in the guaranteed delivery of the events, which we are going to solve it. After that, we can use this solution for rebuilding the state for the application master. So any application runs, machine goes down, it can rebuild its states. So please go look into these Jiras. Slow machines. We don't have solution for slow machines as of now, because we don't know whether the application, if the machine is slow or the application and the job is slow for some reason. We can solve this problem from outside automation monitoring system. We can have scripts which can monitor the nodes and see if that particular node has some problems and bring that node down and do out of the rotation. But inherently in the framework, we don't have this solution. We need to work. We don't have any right now. We don't have any solution for this. Flaky network. So this is a big problem. The problem here is the split brain problem, right? Suppose there are two application masters. So one application master is running, and the network goes down between data node and the resource manager, where the application master is running. It starts a new application master onto another machine, and this machine comes up, which resource manager thought that it actually went down. And then it's a split brain problem, right? You don't know which one is the good one. We solve this problem in MapReduce. We have timeouts where we can wait for some amount of time, and then we start the new application master. And after that, if the previous one comes up, we'll say you are the bad one and shoot it on the head. But we solve this problem for the MapReduce. But for all the generic application, we have to solve this problem into the application masters. Whosoever is writing a new application, please look into this. This is a big problem, because the network can play up, and you will have these problems. And then you will have all kind of data problems, because if the two application masters are running, then you will have a corruption of the data. Out of memory errors. We have so many jobs which are running more than 200K tasks, 300K tasks, and the application master is like another task, right? It's running. So these are the parameters. You will have two kind of memory errors, which is physical memory errors and the virtual memory errors. The physical memory errors, you can tune these two parameters based on the applications you are running. We are running by default 4 GB of container for one application master. You can have a different memories for your task as well as the application master. So please tune these parameters. This is very important, because otherwise your jobs will fail due to out of memory errors. There is another thing, which is virtual memory. If you have enabled virtual memory monitoring on your machine through Yarn, then even you haven't use the full physical memory, but the virtual memory is going out of the limits, then it will also fail. The containers will fail because of that. It reaches the memory of the virtual memory. The default ratio is 2.1, which is if you are using a 2.2 GB container for AM, the default virtual memory limit is 4.2 GB. Even if you are not using 2 GB of physical memory, your virtual memory can use 4.6 GB or whatsoever, right? And the container goes down. The yarn will kill the container. Please tweak these parameters, which is very important based on your applications. We face a lot of such issues because we have so many big jobs, and as soon as you have big jobs, you will get into these errors because the application master has to keep up with all the tasks. And these memory plays a big role there. Binary compatibility. This is a big feature. We developed this feature to run Hadoop 1 jobs without compilation on Hadoop 2. It's a big win for user. They don't need to compile their jobs. They take a Hadoop 1 jar, just run into the Hadoop 2 cluster. We worked on this feature, and it works well. So the binary compatibility will come with the two things. One is the MapRead API. So in Hadoop 1, we have two kind of APIs. One is MapRead, and the other one is MapReduce APIs. So the MapRead APIs, we did the binary compatible. I mean, you just go take the jar, run it on the Hadoop 2, and it will run. If you're using MapReduce APIs, then it is source compatible. What it means is you have to compile your MapReduce APIs jar with Hadoop 2 jars. But the APIs will not change. There is no change in the APIs from Hadoop 1 to Hadoop 2. So that is what it means. You don't need to change your code. You just need to compile if you're using MapReduce APIs. You don't need to even compile if you're using MapRead APIs. But everything comes with a but. Only works for the 70% of the applications. Why? Because our users are so creative. They use reflections. They use private APIs which not supposed to be used through reflections. And we remove some of the private APIs through Hadoop 2, right? Because we thought, okay, this is Hadoop 2, we are developing new APIs, we are doing compatibility tests, but this was a private API, so we removed it. We never thought they are going to use this way. So this is one of the use cases. I mean, if you guys are using Scooby, we actually went ahead and changed the Scooby code because of this, because they were using all over private APIs through reflections. They use Uber jars so what they do is, users, they package all the Hadoop previous jars into their jars. And in that way, you get all kind of class mismatch exceptions. Because they don't even get to the Hadoop jars which they're supposed to use because they are using the old jars because they have packaged them. And this is very hard to debug. I spent days to debug these kind of issues. Because you never know, I mean, you don't know what the hell is happening because you have jars and everything should work and the user have some class package in their jar and then you have to actually debug each and every jar which they have. It's nightmare. So please be careful of these things. This is very important. Otherwise, this thing works very well, binary compatibility. This is the MapReduce Jira. Please go ahead and look at it. You will find all the changes which we did in terms of making the compatibility between Hadoop 1 and Hadoop 2. Other thing is LZO compression. If you guys are using LZO compression, till now, I think till February or till March, there was no LZO library available which was compiled for Hadoop 2. We found it just before one day of upgrade. Some user didn't tested their jobs, was using a LZO text input format, and he complained, we cannot upgrade because my job is not working. And then we found out, okay, debug, we spent the whole night, find out what was the reason, then we found out we don't have LZO compression library, which is compiled with Hadoop 2 code. We compiled it, we deployed it, everything was working. But yeah, this is the important thing. If you have I think Twitter has their GitHub, I think everybody's using that, which have LZO code base. Please compile it with Hadoop 2 libraries. It's important. If you're using Avro, there are a lot of libraries for Avro MapRed, which you will found on the internet, but this is the right one. We found out after so much research that, okay, this is the right one, which is compiled with the Hadoop 2 version and works well for Hadoop 2. Please make a note of it. If you guys are going to deploy Hadoop 2 very soon. So another problem which we face through log aggregation. In Yarn, we have, this is a very nice feature. It gives us so much flexibility for debugging jobs. What it does is, how this feature works is, it actually, once your application is finished, and if you have enabled this feature, it will aggregate all the logs from all the data nodes and put it into the HDFS for a single job. You can go ahead, look into the job, do analytics, do whatever you want. It's a very good feature. But it loads a lot of data into the HDFS. We are generating around 5 to 7 terabyte of data per day of logs. It's a lot of space. And there is a problem. Its default is 30 days. We haven't looked at it was 30 days. We found when our name node went down because of this. So please, this is a property which you need to change. We change it to the 4 days. Please change it to based on your load. Otherwise, your namespace go out of space and lot of issues. And this actually loads a lot of load on the name node. I think it does more 40 to 50% operations more on name node because of the log aggregation. So please, whenever you upgrading Hadoop 2, make a note of this. If you are enabling log aggregation, it's a very good feature. However, you need to increase the heap size of your name node based on the namespace as well as the operations which we are doing. It's at least 30 to 40% operations which will increase because of this. Another thing is user engagement. So you guys, whenever you going to upgrade your cluster, please engage all users verifying all the jobs. What happens is usually what happens is people say, okay, I have 10 jobs. I will run one job on some 1 hour of data and everything is good, right? It doesn't happen that way. You will face all the issues when you deploy in production, and then you will face all the issues, and then users will come, okay, my jobs are not running. So and then you have to spend nights there to fix their jobs because they haven't tested it. Please engage all the users. That's very important. Test with the production-like data. Copy the data, test the job with the production. Otherwise, you will not found these issues like memory issues and all these issues before, and then you will face these issues in production, and which is actually a revenue loss, right? Which you don't want to do that. Verify all jobs, not the sample jobs. That's very important. We talked about a lot of bad things. Let's talk about some good things. What we found out in Hadoop 2. Let's talk about numbers. So I ran all the benchmarks of Hadoop on, I think, 300 node cluster. First with the Hadoop 1, and then with the Hadoop 2. These are those numbers. This is the Jira. Please go. I uploaded all my results there. It tells you about the cluster size, disk, cores, everything. So in the sort benchmark, we are around 20% of improvement just to run sort on the same hardware, on the same machines. For the TerraSort is about the same. Shuffle is 2x increase. If you run the same benchmark of shuffle, it's 2x increase. Scalability, if you run suppose 100,000 tasks in job tracker and in resource manager, we are getting 4x increase in runtime. Please go look into this Jira, Yarn 938. I have uploaded all the results there. Go and check it out, all the data. It tells you about the cluster, it tells you about everything, what we ran. So this is a task. So I did the analysis on how the tasks were performing in Hadoop 1 and Hadoop 2. So the task starting per hour is actually 60% more tasks. I'm starting per hour on Hadoop 2. There is nothing change. Same hardware, same machines, just we change the Hadoop 1 to Hadoop 2. I mean, Yarn to Hadoop, job tracker to Yarn. Task finishing per hour is 52% increase. So we are starting more tasks and we are finishing more tasks, at least 50%. This is app submitted per hour, which is increased in 51%. And apps finishing per hour is increased 50%. This is the Hadoop 2 utilization of the cluster. If you look into this, it's like when we are in peak, we are actually using the whole cluster, which was not the case in Hadoop 1. Because you cannot use the whole cluster in Hadoop 1 because you have the hard partitioning of mappers and the reducers, right? So this is pretty good. We are utilizing our cluster to the full extent when we need it. Overall improvement, overall job throughput increased 2x. Overall runtime of the jobs, we actually analyzed our critical customers' SLA jobs which runs on the cluster. And we found out we increased their runtime we decreased their runtime from 1.5x to 2x. So this is the number. So actually this is, if you think about it, we actually, without doing anything, we kind of increase the hardware. We increase the compute in our cluster, right? It's like half of the cluster we increase. Like if we have 2,000 nodes, we increase 1,000 nodes by just these numbers, right? Job throughput. We did nothing. We didn't increase any hardware, but still we are getting the compute of more 1,000 nodes. If you compare with the Hadoop 1, that's pretty good. It's a lot of money which we saved. After that, we are now able to run Tez. We are now able to run Storm. We are now able to run Shark and Spark in same Hadoop cluster. We don't need to run more clusters, right, for Storm, or we don't need to run Shark and Spark as a different cluster. We can just run on Yarn. It gives you, and there are so many applications which we run. H2O, somebody released H2O and now our users started using it. So, it's a lot of new applications which enable because of Yarn. It's a huge win for us. We have name node HA as a part of Hadoop 2. Now there is no single point of failure for name node. We have RM restart. Even if the RM goes down, we can restart and there is no user have to submit their jobs. RM HA. We have HA on the resource manager. Rolling upgrades, which is going to come in the next release. Based on the availability, based on the numbers, I think there are, if you go to upgrade to the Hadoop 2, there are some pain points. You have to do a lot of testing. You have to plan for it. You have to work with the users. But actually, it's worth of the effort. You will gain a lot in terms of compute, in terms of availability, in terms of user experience, and what your users can run on that cluster. So I can take any questions if you guys have. This is my email ID. If you have any more questions, you can send it to me. Sure.
Did you get the X2 performance improvement using the same reproduced jobs?
I couldn't get, can you?
Did you have the performance improvement with Hadoop 2 running the same MapReduce jobs? That
Yes, yes. So that's what I showed here. We did the analysis of our user, and for some critical MapReduce job, the same jobs, same data. There's no change in the data. There is no change in the job, and they ran 2x faster. So I mean, it depends upon job to job actually, but the jobs which we analyzed is basically running 2x faster than Hadoop 1.
Speaking about your next step, maybe. Okay, now you have Yarn as MapReduce platform. Have you made already some investigation about test potential? What do you expect from this? As I understand this next step.
So next steps are very clear. We are adding more and more use cases to our clusters. Like we are adding Storm, we are adding Spark and Shark, we are adding interactive queries, we are using Thais. So it's more about how well the Yarn is giving you all these building blocks you can use, right? So now you can add new functionalities. Like if you want, so the now analyst wants their queries to be as performant as like you do in a SQL, right? For the big data. So all these interactive queries will be enabled. All these streaming functionalities will be enabled.
But have you made already practical steps to upgrade? Have you tried something on tests already to?
Yes. So we are right now.
And what are the results?
Okay, so the results for the Thais, I don't have it right now, but the results are very good. I mean, we are right now testing, so we didn't have any formal release of Thais in our cluster as of now, right? Or we didn't have any Storm release as of now. But yes, we are testing it, and the results are really good. We are benchmarking all the previous query with the new queries, I mean with the Thais, and then finding the results and tweaking the Thais itself if we can find out any opportunity to fix it, and then benchmarking again and again. So once we will be better, whatever we are running right now, we will release, and we'll release the numbers in the open source.
We saw this improvement of it's multiplied by 2, but what was the reason? And also, I mean, this is specific to your jobs, or this should be the general number?
So the reason is very simple. The reason is we don't have any hard partitioning in Yarn in map task and the reduce task. And because we remove all these heavy lifting from the job tracker in the resource manager, so jobs are able to start fast or finish fast. That is one reason. Second reason is we don't have any hard partitioning between mappers and reduced tasks, and that is the reason your jobs don't have to wait in the queue even if the capacity is available, right? So this is the basically two reasons. Because of those, the jobs are starting. We're getting these results. I mean, this is a general number. If you run your same jobs on the Yarn 2 cluster, you will find the similar results.
One small maybe question. Have you noticed difference in results of failures and mean failure on your cluster? It's pretty big, and as I have seen your graphs, your average cluster usage is going up because of more resource usage. Is it critical to failures? Yeah.
So cluster utilization is fast, is more. The reason is because we are able to use the whole cluster. So what happens in Hadoop 1, it was you are not able to use the cluster even if the capacity is available, right? And that is why the utilization is more. You don't need to wait in the queue if the resources are available. In Hadoop 1, it was not there. So yes, the failure scenarios, the failure is not different than what is Hadoop 1, right? If the node goes down, the task will again be started. So this is the same behavior. There is no change in the behavior in terms of failures. However, because you are capable of running the task even if the capacity is available, that is how the utilization is going up.
One question about benchmarking. So, what kind of strategy did you choose for that? Did you benchmark in like isolation? You have a separate testing cluster?
Yes.
Or is it like a production cluster? Are there
no?
Like
it's a separate. I used a separate cluster for 300 nodes. I mean, I think 250 or 260 nodes. It's a separate cluster I used for solely for benchmarking, and so that if you go to this Jira, it have all the results, the characteristics of the clusters, what are the nodes, what are the machine, what is the memory, what is the size of the disk and everything. And then we ran Hadoop 1, and then we deployed Hadoop 2, and we ran it, and then we found these numbers. And I published this on this Jira. You go ahead and take a look.
Okay. You have also mentioned testing on like almost production data, right?
Yes.
Do you have any like strategy for that? Is it like random sampling, or is it like like you choose like by
No,
hand?
we haven't done any specific sampling or of the data. It's just random data which we choose. I mean, for these benchmarks, you can generate the benchmark data, which is actually we generated the same benchmark data for Hadoop 1, we generated the same benchmark data for Hadoop 2, and we ran our tests. So there is no difference in the data in terms of benchmarking.
In this benchmark, you use this like special benchmarking, right? It's not like production jobs, right?
No, it's not production jobs, but we ran, we used our users to when the same on the same data. So this number, right? This one. So we ran our users. We asked our users to run on the same data, the same job. They haven't changed any change in the job. They haven't done any change in the data. The same data, and the jobs are running on the production cluster on the same environment, 2x faster.
Okay. Thank you.
Two questions. Did you write any custom application for Yarn? And second question is, did you have any case where you switch the logic from MapReduce to some other custom application, and which was suitable for what we wanted to do and noticed any improvement?
So if I understood the question correctly, the first part of the question is, did we create new application other than MapReduce? I mean, yes, we run multiple applications other than MapReduce, like Shark. So our Shark and Spark, it runs on our cluster right now, and distributed shell, and there are a lot of other applications people are using, like H2O, in our clusters. They have their own application masters. They run their jobs. I mean, this is users, right? We provide the infrastructure to the users, and they run their jobs. So they are using multiple applications other than MapReduce in the cluster. I couldn't get your second question.
Okay, so first of all, did you write any custom application? I mean, not reusing an existing new application, but rather using the Yarn API to write a new application?
No.
Okay. And second question is, did you take any existing logic which used to be MapReduce and reused another type of application, and what were the performance or other implications?
So we haven't migrated any job from MapReduce to some other kind of application, because definitely people will be using it, will be doing it as a users. But for me, I haven't done any experimentation on that.
I wanted to ask you about methodology or tools which you used to adjust parameters, which you've shown if you've been using any tools to adjust parameters on cluster, or you've done it by testing on Leaf environment.
Most of it, the parameters are basically trial and error. I mean, you get the problem, you find out the solution, and then you find out, okay, what should be the right parameter for this. There is not a script or a tool which we developed which can, give you the list of parameters. But I found these parameters which are very important for you to upgrade to the Hadoop 2, and that's what I'm sharing. I mean, but I found these parameters through, testing jobs in the test cluster and then deploying in production and find out the problems and find out the solutions. I don't have any tool as per which give you the list of parameters. Any more question?
We have time for one more question.
Okay, regarding to MapReduce jobs that are built using MapReduce API, I mean MapReduce package, outside of source compatibility, did you have any serious issues with this?
No. So if you're using MapReduce API and you're using the way it should be used, there is no problem. You can just compile it and it will work, which is the case in our deployment.
So as I understand you have no problem with this.
No. Right. Please follow the Jira, which I pointed out. You'll find out. And I'll be here if you guys have any more questions, or maybe just send me an email. Thank you. Thanks for your time, guys. Thank you.